It has been about 6 months since I made a video, and part of the reason is that about 6 months ago on the forums, there was a proposal for an R47 calculator layout. Now this calculator does not exist, but the idea was what would it look like if we did create such a calculator? And the three keys that have been extremely interesting to me are the replacements for the sine, cosine, and tangent, where we can put the F shift and G shift keys to have direct access to the G shift, and also to have access to these keys up near the top of the calculator. This has been very interesting to me. So I made stickers, very crude stickers, and put them on my C47 about 6 months ago. And I figured at the time, eventually I would get tired of this and return back to just the normal C47 calculator. And I would resume making videos at that time when I got tired of these stickers. But what I've noticed over time is that I'm not getting tired of these stickers, and basically I'm now in the position where I refuse to take them off. I've even upgraded them. I ordered some from Spiff 72, some actual key stickers, and put them on my calculator, and they're on there, I would say, permanently at this point, because I'm not willing to give them up anymore. And then in addition, since I had to put these stickers on those three keys, that means I needed to change the G and shift and F shift labels above those keys. So I made a strip of paper, just printed it on my inkjet, and put that on the calculator as well. And that gave me the opportunity to also change the pi key. So since I made the primary key, now I put a stack roll up function on the roll down key. And I also added two new features, which are called push and pop, which are just programs I wrote that I'm evaluating whether or not they're really that useful. But I think in general, I've been using them quite a bit, and I think they're becoming more and more useful as I get adjusted to them. So I'll show those features. But with all that said, I also have learned how to modify the menus of the C47 by basically replacing them with my own version of each menu. So I've now also done what I think are improvements to a number of menus. So I want to start out just by showing you what I've done in the key layout. So I'm going to open up the key menu, and I want to point out that I still use this yellow key anytime I'm operating down here, especially for programming and any of these functions down here. And then I use these two keys anytime I'm operating on the top half. The blue shift key here in particular makes this row of blue shift menus very, very useful since they're so easy to get at. And so that's where a lot of my modifications have gone. So, but if we look at the key map, we'll see I've changed the primary keys, pi, F, and G, as you can see. And then on the the F shift layer, I put the roll up on the roll down key, and I put push on what's now the pi key. And I've replaced the matrix menu with my own matrix menu. I probably won't get into that on this video because there's too much stuff to talk about right now. And then on the G shift, I put a new complex menu, a new stack, a new trigonometry, and a new clear menu, all basically customized for what I think is more important than what's in the default menu. And I put the pop function on the pi key. Those are the only changes I made there. And now I kind of just want to show what these new menus look like. So this is my new version of the complex menu. It has about half of the same things that are in the existing menu. And just to keep things real easy in terms of returning to the existing complex menu, whenever I modify a menu, I always put the original menu in the G shift F6 position. So this top place. So I can always go to the original menu like this, and I can return to my menu at any time. So this is the menu I prefer right now. In particular, I really like how these tagged operations work. So if I want to make a complex number 1, enter 2, complex, I can switch it to polar coordinates in degrees or polar coordinates in radians. Once it's in degrees, I can break it back onto the stack as in polar format, or I can put it back into complex, convert it to rectangular, put it back on the stack. I can enter a value on the stack like 1 and 45, tag it in degrees, make that a complex number. All the while, I leave the calculator's operating mode in degrees and Cartesian coordinates because everything I need to do, I can do right from this complex menu very easily. So yeah, this is my complex menu that I really like a lot. Let me just clear that out. And now I want to show let's see, which one should I show next? The trig menu. So the trig menu is also very important on this calculator now because I no longer have primary keys for any of the trig functions, so sine, cosine, tangent. So it's important that my trig menu has these in the bottom row so I can get at them very easily. And again, I do the degrees, radians tags so that I don't have to switch coordinates. So if I want to take the cosine of 45 degrees, I just tag it and take cosine. I don't have to worry what format I'm in. Or if I want to take pi divided by 4, tag that in radians, and take the cosine of that, I don't have to worry about the format of the calculator I'm in. So yeah, this is my trig, and then this is the original trig menu, which I can get at very easily. Okay, and then the other one I want to show is the clear menu. So I use clear a lot. I don't know why. Maybe it's something wrong with my my brain, but I like to always have a clear stack when I'm starting out so that I can see what's happening. And then I've made this heap function, and on the forums somebody gave me a very easy program to do a 4-level heap, but I've since modified that now to make it a heap that can grow and shrink as needed. So I need a clear heap function, and then I put the clear mod function also in the clear menu. This is what you get, I think, if you do a triple press of exit, but I pretty much moved away from all of the double clicks, triple clicks, and long keyhold operations. I just they still exist, but I dispensed with most of them, or I dispensed with all of them really, so that I can just directly get what I want. So I put that clear menu in that clear mod function in the clear menu. So pressing that clears out all the old menus. I think it resets a couple of other things, but I don't really remember anymore right now. I looked at one time, but it always returns me to this known state. So for me, it's very common to open the clear menu, do the clear stack, clear the heap, and clear mod to get back to the home menu. And I'm always using now the home menu, and my menu I'm leaving alone. So I'm not modifying either of these very much. My menu I leave like this. The home menu, I put in the programs that I use, the ones that are not utilities that go in the main menus of the calculator, and then all the other functions that originally I was putting in my menu, I've really pretty much just customized the complex menu to hold those instead, or the trig menu, or the stack menu. Okay, so here's the stack menu that I've also modified. It has this push and pop features now, and the clear heap feature as well. So maybe I'll just briefly show how the stack or the heap works. Basically, it's not the same as the stack. So the stack, as we know, is either 4 levels or 8 levels, and we can see the stack always by going to the registry and showing it here. So these 8 levels are the stack, and where I put the heap now is starting at register 99, going down from register 99. So basically it sits below the stack in this registry viewer. Register 99 I use as the heap pointer, so it points to the bottom of the heap, and then anytime I push something on the heap, register 99 will tell me where the bottom of the heap is. So just to see how it works, if I exit out of this, let me push, do a 1 push, and a 2 push, and a 3 push onto the heap. And then just to make it clean, let's also put a 6, 5, 4 onto the stack. So now if I look at the registry, I can see that on my heap I have 3, 2, 1 pushed down, and on the stack I have 4, 5, and 6 pushed up on the stack. So I can easily then just exit this. So I can now pop my 3, 2, 1 off the heap, and then just to make it clear, I can push these back onto the heap. And since the heap will grow indefinitely, I can push as many numbers onto the heap as I need, up to the limits of the registry. So the register, this register holds 100 entries. So I don't use these for anything else, or I rarely use them for anything else. So my heap could grow to 100 entries or thereabouts, 99, 98 entries, since I have a heap pointer. So it's pretty nice feature from my point of view. And there was a question like, how do you use it? So I just want to show one example, and then I'm going to end this video because it's very long. But here's the one example that made me want to start using the heap. And the problem, this example comes from, let's clear this out, comes from this square or cube root of -8 problem. So if we put -8 on the stack, there's at least well, I have three ways to take the cube root of this. So one way is to just go 3 and go 1 over 3, so 1/3, and then use the y to the x. And this gives us one of the roots of -8, one of the cube roots of -8, a complex number. Another way to do it is to put -8 on the stack, and then put 3 on the stack, and use this xth root of y function right here, this g shift, and that gives you a different root of -8, different cube root of -8. And there's a third way to do it. If we recognize that this is a cubic equation, we can put 1, 0, 0, 8 on the stack and have this represent a polynomial. So this 1 represents x cubed plus 0x squared plus 0x plus 8 equals 0. That's the same as saying x cubed equals -8. And then we can use the cubic solve function that's in the advanced menu. So it's on the G shift of the F2 key. And this will return all three roots, all three cubic roots of -8. So this is where I was when I wanted to, when I decided I wanted to use the HEAP, because one thing you would do at this point, or that I would like to do at this point to show or demonstrate that these are all cube roots of -8, is to take each of them and cube them. So if I cube the first one, and I don't have a HEAP at this point, I just want to roll it out of the way. So I would roll it around to the top of the stack. And this works quite nicely, especially on the free 42 and the DM42, where the stack has an infinite depth. So it's an end stack. So I would never lose anything that I roll around to the top of the stack. But here, where we only have 8 levels on the stack, I will lose anything on the top of the stack as soon as I do another operation that does a stack lift. So since I want to cube this guy, I do 3 and then y to the x. So I get the fact that it's 8 as well. But now if I want to bring back my original, my first one that I cubed, and I try to roll it around, I get a 0. It's been pushed off the top of the stack. So that's the reason I wanted the HEAP. So just to make this clear, let's clear this out and do this problem one more time. So I'm going to do 1, enter, 0, enter, 0, enter, 8, enter. Go to advanced menu and find the cubic root. Solve the cubic equation. And then I would want to verify this by doing y to the x. And then I'm going to open up my stack menu, and instead of rolling the stack, I'm going to push it onto the HEAP. And then here's another one that I want to try, y to the x, to show that it's also 8. And I want to push it onto the HEAP as well. And then the last one I would do, of course I can see that that's 8. And then the previous two values that I pushed on the HEAP, I can now pop off. And this is how I can show that all three of these roots, when cubed, actually equal -8. So this was the impetus for creating this HEAP. And if I push these guys back on the HEAP, I can save them for as long as I want. And if I look at the registry, I can see here they sit on the HEAP. So this is one way I use the HEAP. There are other things I do with it, but I'm going to save that for the next video because this one's gotten already quite long. Thanks for watching.